So Hooke's law is apparently f of x equals k times x for a spring, where k is a constant and x, I think, is the change in stretch in the spring. So like they say, it starts at 10 centimeters, goes to 17 centimeters, so it's a change of 7 centimeters. But I think the other trick is that joules are in terms of meters. So we need to figure out what that constant k is. So we're going to find out, we're going to create a work equation for it. We're told that 6 joules, that should equal the integral from 0, the starting amount is at 10, to 17. So that's a change in 7 centimeters. So that's 0.07 meters, right? And then that's k times x dx. So that's just a straightforward integral. It's k x squared over 2 from 0 to 0.07. And then if you plug in 0.07, so we got 0.00245. And then finish solving for k by dividing that from both sides. So this is what I get for k. I think the final answer is supposed to be an integer though, so we'll carry that, a lot of those decimals out. Probably don't need that many. We could probably spot the integer in the end. But that's what k is. Now we can answer their question, how much work? So we're stretching from 17 to 24 centimeters. But remember, it had a natural length of 10 centimeters. For this, for the work calculation, we want to take an integral. 17 minus 10 makes 7, so that's 0.07 to 0.12. Because I'm calculating the distance from its natural length to 24. And that's 12 centimeters, so 0.12 meters. Oops, so I caught a mistake. It's supposed to be 24 minus 10 makes 14, so 0.14 here. We can factor out that k, do the limits of integration, and we know what k is. I just didn't want to write that number a bunch of times. So if I plug in 0.14, 0.0098, and if I plug in 0.07, 0.00245. Okay, so if we subtract those two, and then we multiply by k, that will tell us the force in joules. Oh, 18 joules for this question.